Hello everyone, welcome to today's webinar on Gen24 and its backup capabilities. My name is Sriram and most of you know me as Sam. I am the team lead for technical support under Fronius Australia and I'm based in Perth, WA. And today I have the pleasure of introducing you to some of the cool features on Gen24 and its backup capabilities. All right, so without further ado, let's jump into the webinar. I will cover some of the unique design and great features of Gen24 and the differences between Gen24 and Gen24 Plus. So one of the questions we always get asked is, what is the difference between Gen24 and Gen24 Plus? So if you look at the hardware, they are exactly the same. So Gen24 has the same hardware as a Gen24 Plus. On the Gen24 inverter, the battery inputs and the full backup function is not yet active, while Gen24 Plus, on the other hand, already has the battery and full backup activated by default. Please note that it is possible to activate battery and full backup on Gen24 by purchasing the license required from the web shop. We call this Fronius UP.storage. So let's take a look at how to do this Fronius UP.storage. This is exactly the same page on webshop where most of you might be familiar doing a product registration or warranty extension. Now, if you are logged in as an installer, you will now also have the option to choose upgrade. And once you have selected the inverter that you want to upgrade, please click on choose upgrade and simply check out from the cart. Please note that the Fronius UP.storage upgrade can only be performed by an installer, and it is not currently available for end customers. So one of the things to keep in mind is to make sure that you are upgrading the correct inverter serial number, and also make sure that you have the inverter online so that we can do this license upgrade. Moving on to the main topic of this webinar, which is backup power. So let's begin with Gen24 inverters, and later we will take a look at Gen24 Plus. So the only backup power we can do on a Gen24 is PV Point, which is an integrated backup power function on the inverter. And all models, or irrespective of the phase configuration, have got this PV Point available as standard. So whether it's a Primo or a Simo, you have got PV Point by default. So what is PV Point, or what is this basic power supply, backup power supply? So PV Point is a socket which is supplied during a power outage or when grid conditions are out of feed-in limits, so it can be really high voltage, no voltage, or low voltage, ensuring that important loads can be supplied. So PV Point is an integrated backup power function without any additional cost. So we call it a free basic backup power supply, and it can be used with or without a battery. So if you have a Gen24 Plus inverter, you could have a battery added to the system and you can still run a PV Point instead of full backup. And when you're using PV Point without a battery, we are completely relying on just the PV array to cover the loads. Hence, without a battery, PV Point can only be used to back up loads in the daytime. Right. So what are the capability of PV Point? So if you look at the output power ratings, you can see that for both single phase and three phase model, the continuous power rating is about 3 kilowatts. But for 5 seconds overload, the Primo inverters or the single phase inverters have about 4.7 kilowatt possible, whereas these three phase inverters have 4.1 kilowatts. So please note that it is possible on all inverters, not from 6, 8, and 10, actually from all the way from 3 to 10 on Simo, you can still do PV Point. So regarding this output power, the 3 kilowatt, that is one of the important topics to consider, where you don't have to overload the backup that you're supplying if you were to only connect PV arrays that we don't supply more than 3 kilowatts. So PV Point wiring. So In Australia, PV Point is considered as a final subcircuit, so it has to be RCD protected. So the neutral line must maintain continual connection back to the main switchboard, and hence it is recommended to not use GPOs with inbuilt RCD and rather have them separate in an enclosure where you have separate RCD and separate power point. Moving on to configuration of PV Point, how and where to turn on this function. So you can activate PV Point on the web UI of the inverter by going into device configuration. Under functions and IO, you can turn on backup power mode and set the full backup to PV Point. So backup power mode can be set to PV Point, but of course you can also activate this function when you initially commission the inverter. It is one of the steps under product where you can turn on this backup power function. All right, let's move on to the backup capabilities of GEN24 Plus inverters. So with GEN24 Plus, we can do both PV Point and full backup. So PV Point now, it is exactly the same as on GEN24 inverters. So I'm not going to talk much about it. So let's move on to how to do full backup on the GEN24 Plus inverters. So with regards to full backup on the single phase Primo range, we have full backup possible from 3 to 10 kilowatt inverters. But on the 3-phase ranges, we do not have full backup available on 3 to 5 kilowatts. So it is only possible to do full backup from 6 to 10 kilowatt on the SIMO range. That is one of the important topics to consider. So let's move on to the full backup. So as we all know, to run the system in full backup, we should not be connected to the grid. So we can either have a manual changeover switch or an automatic one, depends on how you want to do it. But one thing is, like, a battery is not really mandatory to have full backup, but it is recommended to avoid overload trips. And battery is necessary if full backup is needed at nighttime, because at night we don't have sun. So unlike PV Point, full backup, in a system for full backup, we must have a smart meter in the feeding point. But please note that the smart meter should be outside the backup circuit. So when the system is running in backup, the smart meter is not power supplied. With regard to the SIMO inverters, in full backup, we are able to do a real 3-phase backup up to 10 kilowatts. And with a GEN24, you can actually also charge the battery while we are running the system in backup using the Multiflow technology. But please note that GEN24 Plus is a grid-connected inverter with emergency backup. So we'll be looking more in detail at how to set up automatic changeover for full backup in the upcoming slides. So before that, let's take a look at what is really possible with the full backup and what are the output powers we can do. So as you can see from the table, the continuous output power in full backup is actually the same as the power class of the inverter. So if you look at the continuous power of a SIMO 10 kilowatt inverter, it can do 10 kilowatt backup. Similarly, 10 kilowatt single phase inverter can do 10 kilowatt continuous output power. So in backup, the 3-phase inverters produces power phase unbalance. And the max continuous power in a phase for a SIMO inverter is about 3,680 watts. So on SIMO inverters, if you go over 3,680 watts in one of the phases in backup scenario, the inverter will go into an overload trip. This is something you will need to consider to avoid overload trips when setting up a full backup circuit. All right. With regards to full backup, when you want to add a battery, let's take a look at what are the possibilities. So in Australia, currently we have BYD HVM and HVS battery that are compatible with the inverter, but still there are some limitations on which model can be used with which inverter. So please make sure you are using a compatible battery model with your inverter. It is also possible to parallel multiple towers. Please note that you might need a DC combiner from BYD when connecting batteries in parallel. Technically, it is possible to connect up to 3 towers of BYD in parallel. And the biggest battery capacity you can achieve is about 57.9 kilowatts with 3 times 19.3 kilowatt HVM battery. All right, so another little cheat sheet. So with regards to different combinations, here we have different capabilities of charging and discharging with the batteries. So the chart here shows the DC charging and discharging rate of different inverter and battery combination. An example scenario to consider is the charging and discharging possibility of a Fronius GEN24 Plus 10 kilowatt inverter with HVS 10.2 and HVM 11 battery. So if you look at it with HVS 10.2, we can actually do 9 kilowatt charging and discharging, while HVM 11 can only do 4.51 kilowatt. So why is this something important to consider? So if you are setting up a full backup circuit and customer needs backup at nighttime, we are only limited by what the battery can discharge. So if you were to install an HVM 11 and the system goes into backup, the battery HVM 11 can only discharge 4.51 kilowatts. Over this, the system goes into overload trip. Similarly, but here using a HVS 10.2 might be a better option because you can do up to 9 kilowatt discharging. All right. Full backup configuration, where do we activate this function? So it is the same place where we turned on PV Point. This is, again, under device configuration. We have the option functions scenario, where you can turn on the backup power mode and set the backup power to full backup. So this can be done at the initial stages of commissioning. You can turn on backup power and set backup power mode to full backup. Or if you've already commissioned the system and later wanted to add this option, you just have to log into the web UI, go to device configuration, functions scenario, turn on backup power mode, turn on backup power and set backup power mode to full backup. Well, as we discussed earlier, we can charge the battery even in backup mode using Multiflow technology. So let's take a quick look at what else is possible with Multiflow. One of the cool features of Multiflow is that we can charge battery from other AC sources on site. So this can be a wind turbine or an existing inverter. It could be a third-party inverter. It could be an old Fronius inverter. It doesn't matter. And here the inverter will take the surplus AC power available from this additional AC source and convert it into DC and store it in the battery. Please note that we will always need to consider the charging and discharging capability of the battery and the inverter combination we're using, as well as the power rating of the inverter, as these are some of the limiting factors in Multiflow. So here we have a diagram of how Multiflow could work when you have an existing system. As I mentioned again, the existing system can be of any brand or make and not necessarily a Fronius inverter. You can also have a GEN24, so you can just have GEN24 inverter as an AC coupled solution without any PV, and thus provide like a full backup to the customer who have an existing system and wants to add a battery and have full backup to his property. So the PV generator can supply here the loads in the household and charge battery at the same time. If there is a surplus, loads supplied and the battery is charged in parallel. And if there is more surplus, it is fed to the grid. But when there is a consumption, power is supplied by the PV generator and the battery. So, all right, where do we turn on some of the features of this Multiflow technology? So to use Multiflow when we want to charge battery from additional AC sources, please make sure you turn on the function allow charging from other generators in the home network when you add battery as a component on the web UI. So when commissioning the system for the first time or whether you add it at a later stage, this is under device configuration components where you add the battery. You have these two options, which is allow charging from other generators in the home network and allow charging from public grid. So if you want to charge battery at low tariff rates from your electricity retailer, you can also turn on this allow charging from public grid, but you would have to set the charging rules under battery management at which time the battery needs to charge or at which time the battery needs to discharge. If you want to know more about this multi-flow, please simply Google Fronius Multiflow Technology, or you have the link here that you can also check out. All right, moving on from multi-flow technology, what if customer wants to show this additional AC source on site in SolarWeb? Is it possible? Yes, it is. It is possible with the multi-smart meter setup. So let's take a look at how to connect multiple smart meters with Gen24. And it can be used to monitor a specific load or monitor production from a third-party inverter or even a wind turbine. So here on the Gen24 inverter, we have two Modbus terminals on the Modbus interface. So they are labeled as M0 and M1. Each terminal can take up to 4 smart meters. So you can connect up to 8 smart meters in total if there are no battery or on pilot in the system. If you are also considering battery, please make sure that primary meter and the battery are connected to different channels, which is M0 and M1. And the Modbus connection between meter, here it is just a series connection. So please make sure that the terminating resistor is installed only on the end of the line. Another thing to keep in mind that is to make sure that each meter has a unique Modbus address. All meters, most of them come with the address number 1. So you can't have 4 number 1s in the same line. So you'd have to number them as 1, 2, 3, and 4, for example. So you'd have to refer to the manual of the smart meter that you are using to see how to change the Modbus address. There's, of course, different meters can be connected in this configuration. It doesn't have to be the exact same model. So in the diagram here, we have an inverter with 4 smart meters, and that is the utility meter. So here we are going from the meter in series to the first meter, which is used as a generator meter to monitor a wind turbine. And we have 2 meters monitoring a specific load path. And then you have a primary meter, which is set at the feeding point. So the end of this Modbus line here is the inverter and the primary meter. Hence, we have the terminating resistors on the last meter, which is the primary meter. And by default, it is also active on the inverter. IT. How do we configure them though? So when you are adding multiple smart meters under the component section on the web UI, once you have already added the primary meter, you have then the possibility to add a secondary meter. Some of the things to keep in mind is you have here production meter or consumption meters. If you want to monitor a specific production, you choose production meter. If you want to monitor a specific load like a pool pump or heater or something, you choose a consumption meter. And here we have the option to also set the meter address. But you might also have to set this on the actual meter itself, depending on the meter you're using. Moving on to the brain of the machine, the data communication PCB. So on Fronius inverter, we are calling this data communication PCB a pilot. Here you have a picture of a pilot. As you can see, it has a wired shutdown terminal, a Modbus interface, and a digital I/O. The Modbus interface has 2 Modbus connections, as mentioned again, M0 and M1 terminal. So it makes it easier for you to connect a meter and a battery. And when it comes to digital I/O, so I/O stands for input-output. So here you have multiple pins which can take input and also do output a signal, whereas we also have some pins which can only take an input signal. So I mentioned here some of the pins that we will be really using for backup. So the IO0 is used to power supply the relay. IN, which is an input, IN6 is used for getting a feedback from the contactor, and IN7 is used for getting a feedback from the relay. So this wired shutdown is the other part. So by default, they come with a bypass connection. If you were to remove it, the inverter will go into standby. So please be careful that you don't remove it in a normal installation. And this is normally used when you want to run the system with a genset that you want to put the inverter into standby when the genset is running. We'll be also taking a look at that. So another topic here is that we have these terminating resistors already as a dip switch. By default, they are both on. So depending on your needs, you might have to sometimes turn it off, depending on where the inverter sits in the chain in the Modbus line. So if it is not the end of the line, you might have to turn these resistors off. The other part here is the LAN cable connection. So you have LAN port 1 and 2. So if you are trying to run a LAN cable to the inverter for internet, please make sure that you're only using LAN port 1, as LAN port 2 is reserved for inverter-to-inverter communication, which is something we will be releasing in future updates with the inverter. So it's not currently available. All right, backup switchover components. So what do we need to run a system in backup when it comes to single phase backup supply? So we have here a fuse, a relay, a smart meter, and a contactor. So one thing you can notice here is the relay and the contactor both needs to have a normally open and normally closed connection. Of course, we are using a smart meter 63 amps here as an example, but please make sure you use the right models depending on the current ratings that you are trying to control. So when it comes to three-phase, exactly the same. Only difference here is you have a three-phase meter and a breaker that can control 3 phases. So 3 normally open and 1 normally closed. The relay has 1 normally open, 1 normally closed. Again, choose the meter and the contactor depending on the current. So here as just an example, 63 amps, but you might need to consider using a 50K smart meter if you are trying to control something larger than 63 amps, for example. So what are the options or some of the examples or options that you can use for a single phase backup? So here you have some examples that we can recommend. So we have Noarc, Schneider, IMO, some of the brands, but please note that if you are buying a contactor with only normally open, you might need to also get an auxiliary which has a normally closed connection. So that is one of simple mistakes you can make, that you only get the normally open and you miss a normally closed side of things. Similarly, when it comes to relay, again, these are the options that we can recommend. So just define the relay with the normally open and a normally closed. And when it comes to three-phase, again, similar scenarios as single phase. It's just that we have more normally open connections possible because we need to break 3 phases. So here you have one IMO which only has 4 normally open on the main one, but then we need an auxiliary which has a normally closed, whereas the Finder here already comes with 3 NO and 1 NC. So this is an example of relay you could use. Again, 1 NO and 1 NC. All right, moving on to the main topic of this webinar. How do we do full backup wiring and how do we commission it? All right, so first thing you would notice here is that the backup is actually outside the inverter. So in my opinion, it's a good thing that if the inverter fails, the customer still has a grid connection available and he's not sitting in the dark. So now for us to run the inverter in backup, we must disconnect the system or the backup circuit from the grid. So we need a contactor to disconnect the backup loads from the grid connection. This is to avoid feeding power back into the grid in a blackout scenario, which could be fatal for people working on the power lines during outage. So to achieve this break, we use a contactor. So you can see the backup power loads are going through the normally open side of the contactor. And the second part is what happens when there is a sudden grid is suddenly reconnected. So if the grid comes back again, we don't want this contactor to reconnect back to the grid while the inverter is still running in backup. So what can we do here? So we can then use a relay, and we can pass the power supply of the contactor through the normally closed contactor of this relay and keep this contactor open while even when the grid has come back on. So now we also, this relay is power supplied by actually the inverter itself. So let's take a look here. So we have here a normally open connection going towards the load, and the power supply of the contactor is coming through the normally closed of the relay, and the actual relay gets power supply from the inverter pin IO0, and we're connected to the ground as well, of course, to complete the circuit. Now, what is the other thing that we need? How does the inverter know that the contactor and relay has worked and it is okay and safe to run the system in backup? And if the grid comes back again, we will not simply connect back to the grid while the inverter is still running in backup. So to do this, we need some sort of feedback from the contactor and relay to the inverter to tell, okay, inverter, I have worked, you are okay to work in backup. So for this, we use the 12 volt coming from V+. So this V+ terminal is always giving out a 12 volt, whether it's grid connected mode or backup mode. So what we are doing here is we take this 12 volt connected straight to the normally closed contactor, and then we run it straight to IN6, which is the feedback for the contactor. In a blackout scenario, we don't have any power supply coming at this contactor, so this normally closed will remain closed. So this 12 volt is able to pass through this normally closed and come back at IN6. So now inverter is like, okay, good, I have feedback from the contactor, so contactor has worked. And it's now waiting for feedback from the relay. So what we do is we also take a connection going straight from this normally closed towards the normally open side of the relay, and we connect it to the IN7, which is feedback from the relay. So when we have the feedback already coming at IN6 from the contactor, inverter is like, okay, I have feedback from the contactor, it will then power supply the relay. So this normally open will now close when it is power supplied, meaning this 12 volt coming from this V+ can now reach IN6, and at the same time it goes through here and reaches IN7. So when the inverter has this feedback from IN6 and IN7 coming from contactor and relay respectively, inverter knows that the contactor and relay has worked, and we can now go into backup scenario. But provided there are also some other conditions we need to satisfy before the inverter goes into backup. So one of them is that there shouldn't be any power supply to the meter, so the actual smart meter should be turned off, or there should not be any power supply or AC connection readings coming at the inverter AC clamps. So if the inverter gets AC readings on the AC clamps from the grid, it knows that the grid has not gone, and it will not switch into backup. This is very basic, very simple connections. If you look at it, it is just 5 connections on the digital I/O plug. IO0 and ground is just the power supply for the relay, and IN6 is feedback from the contactor, IN7 is feedback from the relay, and V+ is where you can get the 12 volt to supply these contactor and relay and get the feedback at the inverter. So very simple. Whether you have a single phase or 3-phase, the idea is exactly the same. If you have a 3-phase, it will be just you have to break 3 phases, but everything else is exactly the same. So if you look at this, exact same connections, IN6 is feedback from the contactor, IN7 is feedback from the relay, and we're just breaking 3 of the phases. And we have here ground and IO0 connected to the power supply of the relay. And we have just a V+ connection going. So pretty much this V+ needs to go through the contactor and relay and come back at IN6 and IN7 for the system to go into backup. All right, so where do we set this full backup? As we mentioned earlier, I think you can go into device configuration, functions and IO, and here you can turn on backup power mode, backup power, and set the backup power mode to full backup. But one of the topics you can see here is the reserve capacity. So what is the difference between minimum SOC and reserve capacity? So reserve capacity is the battery capacity that is reserved to be only used in backup scenario. So when you have set the reserve capacity, for example, to 20%, in grid connected mode, the inverter or the battery will not go below this 20%. And in off-grid mode, we will go down to whatever is the minimum SOC possible for the battery. So if you wanted to reserve some battery power for just to be used in backup scenarios, because you have quite often blackouts, you can set this reserve capacity to a higher value. By default, normally they're coming at 7% when you set the SOCs to automatic mode. But yeah, of course, you can change all these values. So tips and tricks, what can we do? What can we do, or what can we keep in mind when you are building a backup circuit? So things to remember, smart meter should be outside the backup circuit. So when we are running the system in full backup, the smart meter should not get power supply. What would happen is that when the system power supply smart meter is what tells the inverter the grid is back on again. So as the smart meter gets power supplied, it would send the signal to the inverter, grid is back again, and the inverter will just restart, resetting all the contactors and relay to be a grid connected mode. And that's how the system is reconnecting to the grid. So if you install smart meter inside the backup wiring, what would happen is system will go into backup. All of a sudden, smart meter is power supplied. It will tell the inverter, I think the grid is back on again. So system will shut down, trying to reconnect back to the grid. So it'll go in a loop, turning on and turning off in backup. So if you come across that scenario, please check if the smart meter is getting power supplied in backup circuit. Second thing to remember, there's just 5 connections at the digital I/O plug. We have V+ giving 12 volt. We have IO0 and ground power supplying the relay. We have IN6, which is the feedback from contactor. We have IN7, which is feedback from the relay. So if you have only done 4 connections on the digital I/O plug and missing something, yeah, please double check the wiring. Also, another thing to keep in mind, I would recommend using a CAT cable. But if you are using an instrumentation cable or something else, it is not recommended to use anything which is more than 1 millimeter square thickness. So what can we do to troubleshoot the system in case if the backup is not working? So to check, one of the things you can check is you can look up on the device state. So on the web UI of the inverter, you have overview, we have real-time what is happening at the inverter. Next to it, you have device state, which tells you whether the inverter is running or it is starting or it is not running. Normally, when the backup's not working, inverter will try to tell you why it hasn't gone into backup. An example would be you get the message, no feedback from relay or no feedback from contactor. And a lot of times we find that it is just a poor termination. So maybe a loose connection. So if it says no feedback from relay, that is IN7, which is feedback from relay. If it says no feedback from contactor, that is IN7, it's that IN6. So you just make sure they are plugged in properly. And what else can we do? We know that here, all we're trying to do is get this 12 volt coming from V+ to reach IN6 and IN7, but it goes through this contactor and relay. So we can check where we are losing this 12 volt. One of the things you can also do is why we are losing this 12 volt. Like we can check the continuity of the contactor and relay to see if the contactor and relay is really working how it's supposed to, whether it is faulty. And yeah, of course, we also need to make sure the smart meter is not getting power supplied in backup circuit again. And coming to a little trick that you can perform. So if you are unsure whether the backup wiring is the issue or if the inverter is the issue, what you could do is you can take 2 little jumpers and we can directly jump from V+ to IN6 and IN7. So we are kind of tricking the inverter into thinking this 12 volt has come through back as feedback on contactor and relay directly to IN6 and IN7. So normally if the inverter is fine, then the whole system goes into backup. So please make sure that the AC and DC of the inverter is on and the main switch for the site is off, so no supply to the smart meter. And if you still doesn't have the inverter working, even with this little jumper test, when you jumper directly from V+ to IN6 and IN7, please consider the possibility of overload as a reason why the system hasn't gone into backup. Another scenario, which is very rare, that could happen is maybe you try to plug in the cable and maybe damage the terminals. You could reassign instead of IN6 and IN7. You could use IN8 and IN9 as well. So it is not necessary that you stick to IN6 and IN7. You can always use another input terminal. So you have here IN7 and IN8 and IN9 that you could also reassign and use them and see if it works. All right, so when we talk about backup, we should also look at backup with a genset. So you can use the wired shutdown terminal to keep the inverter in standby when the genset is running. And in case if the customer wants to use a backup of the Gen24 and battery combination first before turning on the genset, it is recommended to have a manual changeover switch. So this is to prevent genset from running before the inverter even gets a chance to switch into backup, because we have like a 15-second time frame even with the latest firmware where the backup from the PV system kicks in. So you can again run a WSD even with this genset and full backup, so that we can put the inverter into standby when the genset is running. Here you have a scenario where you can have maybe multiple inverters that you need to put into standby. Again, this WSD is like a series connection. You have these dip switches that you need to take care of. So only on the first inverter it is on all the others it is kind of set to off. Maximum distance between two devices 100 meters, and you can control up to 28 devices using this WSD. Gen24 firmware update. So 1.32, what is the new features on the Gen24? Let's take a look at them. So system power control. So you can now interconnect several Fronius inverter within one system and achieve an export limitation without needing a third-party controller. But to make use of this function, please make sure that there is at least one Fronius smart meter at the feeding point, and all the inverter must be in the same network. So they're talking over the Wi-Fi or the internet on site. They must be on the same network, and you can connect up to 19 slave inverters to one master, which has the meter connected. So in total, you can have up to 20 inverters. You could search the YouTube video, how-to video on dynamic feed-in limitation with several inverters to know more about how to set this up. Export limitation per phase. So as we know, Gen24 SIMO inverters are working phase and balanced in backup power mode. We now have the possibility to do asymmetric feed-in limitation with them as well. So in some countries, export limitation requirements are not just set as the sum over all three phases, but are given for each phase individually. So with this new function on Gen24, we'll be able to provide an asymmetric feed-in that is exactly limiting each phase to the limit set by the NSP. Backup time frames. So with the latest firmware, we also have reduced the switchover time from grid connection to backup mode. And now it takes only 15 seconds to switch into backup. And of course, we will be trying to improve this time in the coming firmwares. But please note that system does take a little bit longer to switch back from backup to grid connected mode because it waits for a stable grid. And we also have to do a grid test timer before we can connect to the grid. Another cool feature that we have now is adjustable frequency in backup mode. So earlier, inverter was always running at 53 Hertz in full backup. This was to kick out any other third-party inverters that are connected in the same backup circuit. But now it is possible to set the frequency anywhere from 47 to 53 Hertz in backup. So if the customer has some appliances or like digital clock that runs faster because the frequency is 53 Hertz, you can now offset it to somewhere between 47 to 53 Hertz that is currently run on the device configuration. Under inverter, you have backup frequency offset. So please note that it is still not allowed to run additional generators in backup along with the Gen24 inverters. or nor can you run multiple Gen24 inverters in parallel in backup. So, all right, let's see who has the first question. All right, so one of the questions, would we need any extra meter to use while AC coupling? So for AC coupled solutions, of course, you will need a smart meter in the feeding point, because we are only charging the battery with surplus energy. So we need to know there is surplus energy. So we just need one smart meter in the feeding point that tells us, okay, there is surplus energy, that you can start storing it in the battery. Doesn't matter where the surplus energy is coming from. It can be any third-party generators, any windmill. It doesn't really matter where it's coming from. But yes, you will need 1 meter in the feeding point, which can tell the inverter to charge the battery because there is a surplus energy. Without the smart meter, we cannot really know when there is surplus energy and not. Another question, how do you run 2 Gen24 Plus in backup? Well, if you want to run the 2 inverters in backup, it is not possible if they are connected in the same network, unless you have it into 2 separate sub-circuits, but you cannot run multiple Gen24s in parallel in backup. So reserve limit. So reserve capacity is set on the web UI of the inverter. This is something you can do when you are commissioning the battery. You can set the reserve capacity. It's not on SolarWeb. It's not on SolarWeb, rather on the web UI of the inverter. Okay, so I hope we have answered a lot of questions. There are still heaps of questions. Some are not related to the topics we have discussed today. So if you have further questions, please feel free to reach out to us at tech support, or you can send us your emails to pv-support-australia@fronius.com. So once again, thank you for your participation. Thank you everyone for joining the webinar today. Hope you enjoyed this webinar and it was informative to you. I wish you all a wonderful evening.